Imagine, for a moment, a time when there was nothing. Absolutely nothing, no stars, no planets, no galaxies, not even the emptiness of space itself. This vast nothingness stretches beyond comprehension. But then, in a fraction of a second, something happened. An event so extraordinary that it would shape the very fabric of everything we know. The moment the universe was born, the Big Bang. For most people, the concept of the Big Bang might seem counterintuitive. After all, we tend to think of explosions as outward bursts of matter and energy. However, this explosion wasn't like the kind we are familiar with on Earth. The Big Bang wasn't an explosion in space. It was the rapid expansion of space itself. Imagine a balloon, but instead of air being blown into it, space itself is expanding, carrying everything along with it. The universe was born from a single point, smaller than an atom, a singularity so dense that all the matter in the universe was contained within it. At this moment of creation, the universe was filled with pure energy, and everything we now see, feel, and experience in the universe came from this energy. The universe began as an extremely hot and dense place, filled with high-energy particles constantly colliding with each other. In the early moments of the Big Bang, the temperature reached over 1 trillion degrees Celsius, much hotter than the core of any star. As the universe began to expand, it's also started to cool. But during the initial seconds, the fundamental particles, protons, neutrons, and electrons couldn't combine into atoms because the temperature was too high. Instead, particles moved at speeds faster than light, constantly being created and annihilated, creating a sort of chaotic dance in the newborn universe. The interactions among these particles were governed by the forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces. But at this point, these forces were so intertwined that it was impossible to distinguish one from the other. The first fraction of a second after the Big Bang is known as the Planck era, a time so brief that it cannot be directly observed, yet it was the most important phase in the history of the universe. During this time, space itself began to stretch and warp, leading to the dramatic acceleration we know today. It's the expansion of the universe. As the universe expanded, the forces began to separate, cooling and allowing matter to form into the building blocks of everything around us. By the time 100 seconds had passed, the universe had cooled enough for quarks, tiny particles that form protons and neutrons, to begin to bond. For the next few minutes, protons and neutrons fused into the first atomic nuclei, a process known as Big Bang nucleosynthesis. During this time, the first elements, hydrogen and helium, were created. These elements would become the raw materials for the stars, galaxies, and planets that we would see form millions of years later. As the universe continued to cool, its size grew exponentially. The first photons, the particles of light, were able to travel freely through space, and this event, known as decoupling, left a faint glow in the universe that can still be detected today. It's the cosmic microwave background radiation. This radiation, a remnant of the Big Bang, serves as a snapshot of the universe when it was only about 380 years old, allowing scientists to peer into the earliest moments of our universe's existence. Looking at this radiation, we can see the ancient seeds of galaxies, stars, and clusters of matter. As space expanded, gravity began to take hold, pulling hydrogen and helium into dense clouds, starting the process that would ultimately lead to the formation of the first stars. The universe was on the path to becoming the vast and complex cosmos we know today. As the universe continued to cool and expand, the next critical phase of its evolution began. It wasn't until about 100 million years after the Big Bang that the universe had cooled enough to allow for the formation of the first stars. Gravity, the force that shapes the cosmos, began to exert its power on the matter that was scattered throughout space. It pulled together vast clouds of gas, mostly hydrogen and helium, forcing them to condense and become increasingly dense. These clouds of gas would collapse under their own weight, and as they compressed, they heated up. This process, called gravitational contraction, created regions of intense heat and pressure at the center of the cloud. Eventually, these regions reached temperatures hot enough for nuclear fusion to begin. This process, the same that powers the stars today, marked the birth of the very first stars. But these stars were not like the ones we see today. they were enormous, thousands of times larger and much hotter. The first generation of stars was made almost entirely of hydrogen and helium, elements created in the aftermath of the Big Bang. These stars were so massive and bright that they burned through their fuel in a matter of millions of years, much faster than the stars we see today. As they burned their hydrogen, they began to form heavier elements, such as carbon and oxygen, in their cores. These elements are the building blocks of planets, life, and everything that exists in our world today. As these stars burned out and died, they exploded in a magnificent process known as a supernova. These supernovae scattered the heavier elements they had created across space, seeding the universe with the raw materials for the next generation of stars, planets, and galaxies. Over millions of years, these explosions led to the formation of galaxies, the great cities of stars that would come to populate the universe. One by one, small pockets of gas and dust began to collapse into larger clusters, forming the earliest galaxies. Some galaxies were formed from the merging of smaller groups of stars, while others formed from the collapse of individual massive gas clouds. As galaxies grew, so did the complexity of their structure. The first galaxies were likely small, irregular in shape, and filled with clusters of young, hot stars, burning brightly and rapidly. But these early galaxies were just the beginning. As the universe continued to age, the first galaxies began to merge and collide, forming the larger, more structured galaxies we see today. The Milky Way galaxy, our home, began its own formation during this era. Like other galaxies, it began as a collection of stars and gas clouds, but over time, it grew in size and complexity, eventually developing into the spiral galaxy we know today. Today, the universe is filled with billions of galaxies, each containing billions of stars, planets, and countless other objects. But it all began with a single event, the Big Bang, a moment of creation that gave birth to everything we know, see, and experience. The camera zooms out to show the vastness of space, with galaxies swirling and stars being born. Attention space lovers, are you fascinated by amazing stories, incredible facts, and the mysteries of the universe? Then you're in the right place. Welcome to Mr. Gloopidoo, your ultimate hub for space exploration. Click the subscribe button now, and don't forget to like this video. And yes, hit the bell icon to make sure you never miss any of our exciting new space videos. So, what are you waiting for? Join the journey through the stars with Mr. Gloopidoo.